Thank you, Victor, for joining us. Viktor Hrtánek. He's going to talk today about template-driven data vault, code-centric approach to master complexity.
My name is Viktor Hrtánek. I work as a data stack developer for Reliance, and I'm coming to speak about the data vault, about the template-driven, also the code-centric, model-driven approach. It's gonna be about the tool which I worked with a few colleagues for the past few years, but don't worry, not a sales pitch. It's gonna be rather technical. Hope you will enjoy. Let's see then what's coming today. At the very beginning, I want to speak a little bit about the motivation, like why we decided to go with this code-centric, template-driven approach. It goes hand to hand with software engineering principles where I'm coming from. As a result, we decided to go with the YAML as a format of choice. Again, I will speak a little bit about benefits it brings. After that, we defined simple hub template, following with a workflow. So once you are done with the templates, how we actually can make them work and generate the code for them. It goes with a small demo of like two examples. One is going to be rather simpler, but the second one will be on a full production model. So hope you will enjoy that one. And as an underlying engine behind this entire tool, we use Snowflake Dynamic Tables, which is one great technology helping you to reduce a lot of complexity by eliminating orchestration, for example, etc. But I'll speak about it a little bit later. Uh, Now I want to start from the very beginning. So usually when you start with a implementation of your data vault project in a large business company, you want to talk to the business. I guess we have here audience of skilled data modelers. I won't spend on this slide a lot, but just to give you a story, you speak with a business, you identify what are your data, what are your structures, what actually matters for a business, and what are the relationship between them. To create your business-driven model or enterprise data model. This model usually serves for you as a blueprint to create your warehouse implementation, in this case, with a data vault. But as a next step, what usually you do, you select your automation tool of choice and you start from sources. Somewhere back in your mind, having the idea that, yeah, well, this is my target picture, but loading a sources. What sounds reasonable, but we don't think that it's so reasonable. And I tell you in a bit like why. Usually you it brings you a lot of patterns which are slightly hidden, not maybe seen at the very first, but especially if you work with the sources which you don't know, something what is not super standardized as SAP, but maybe a legacy system, you tend to load the source and see the tables and start to think like, okay, this is actually hub and satellite, this is a link and satellite, what could slide quite easily to modeling your source somewhere because you are detached from this like table target model you have, and you are too deep into the integration with the sources, uh, drifting you slightly on the side. As well, quite often you integrate source by source. Uh, it's especially problem in situation where you have, for example, S&P split by module, and then you start like, okay, I'm gonna create a hub customer, SAP SD module, and then again, like I wanna have hub customer from SAP SE module, and which you need to harmonize to like final hub customer. But it sounds like a bit of a harmonization in a harmonization layer. And this overhead is actually brought by starting from a source. Another pattern which goes quite often with the GUI-based generators is that when you load your source, there is an implied logic. And by that I mean if you create a hub out of a table, your satellite might get generated out of the box. It sounds like a good automation, but in the end, what might happen that you overlook big tables, like some of the SAP tables having hundreds of columns. If you load them and you don't need them, on the very first stage, on the very left in your architecture, it just brings and snowball the processing complexity towards the data mart. All these, we believe it's introduced just because you are going like vice versa. You should start from your target even while modeling a data vault. Uh, Here I slide a little bit and we'll tackle this one while on a YAML template, but also wanna bring you other design principles we thought are important while building a data vault automation tool. And those are software engineering principles, which are quite often, I believe, overlooked, especially in GUI-driven solutions. And when you think like what makes a good software, it's quite easily you can make it as a good data warehouse and turn them as requirements. I think we all would agree that your data warehouse should be actually collaborative, transparent. You should bring up versioning. This is something what is quite common in software development with all the Git-based tools, not maybe so common in a data warehouse modeling. Uh, and here we think that having like proper version model, not the generated code, but the model will bring transparency, collaboration, versioning. Also, we believe it's important to have something what is maintainable and evolvable. Again, going from a software development where they teach you at very early, like each function should be very modular. So it should solve actually one thing. Do not create a spaghetti code. But then in a big implementation, you have source with many tables. Quite often, if you split on a source level, again, at the very first stage, you introduce dependencies between the object. What brings complexity to your solution, not reduce the complexity. So we thought like, hey, we need a templates which are actually very modular, like Lego bricks. So you can easily take something out, take something in, and it should be fast. Speaking about this performance and efficiency, again, you should not spend like days in your GUI to making a simple changes. Uh, Warehouse should be fast and efficient in a way that if you need to bring a column, it should be really something what you can do in a matter of minutes. With all this in mind, we knew that we want to do template-driven data vault. We didn't know the format. Our very first attempt was also with Excel, what doesn't really meet transparency or versioning or collaboration, but it got us to the on good path. After some exploration, we found YAML and a YAML template, like YAML language, as something what we really could benefit from, because it's a text base, and text base you can define your structure in plain English, what makes it also understandable for business people and people not so heavy technical. But for those who do not know what is a YAML, it is a format, text-based. It's quite often used for data contracts or some kind of a configurations, either big cloud providers, etc. But at the end, this is nothing else than key value pairs. The key could be something as easy understandable as name or age with a value of 28. This is what you see on the left side. Of course, you can make more complex structures, implementing list, what is an array of items, as apple and banana is part of the fruits. We can have a list of fruits. Or you can go even a bit further to more nested structure and create something like an object of similar characteristics. So on the right side, you can see that we might have something like a person, which is defined by name, age, address, hobbies, etc. Uh, the structure you create with YAML is free, so you can make it as you prefer. All what it matters is indentation, and by that I mean using spaces. Uh, no like hidden rules. So with getting these YAML templates, we really could get into something what supports those engineering principles, because you can make like one object in one YAML that goes with the modularity, uh, because you can treat them then independently. Helps a lot down the road when you want to, for example, deploy something really fast. On the other hand, it's easy to version. It's well-known format, uh, means that it's performant. It's here for quite some time, and as well, it's a text base. What supports here the maintainability and availability, evolution, because you can just open it in the editor and change it anytime. Um, Within the YAML templates, we defined all the standard data vault objects, so you can create your hubs, links, satellites. For satellites, we have few variation, like multi-active satellites or aggregated. Not going to too deep details. We also design them in a way that they are strict. You only get what you type, and also we force you to use the exact structure. Meaning, if I speak about these attributes as a, for example, key age, we require you to use the exact structure, not adding anything more, not removing anything. It has to be just like that. Mm, by this, we can enforce that it could be really modular and tied to the data vault objects, which are really standardized as well. In the end, the structure behind hub, it's always the same. Uh, Also, what you can do with YAML templates, you can force this mental model of going from what's important to loading patterns. So if you want to start to think like what I want to model, we designed them that at the very top you have shared attributes which are shared across all objects. You have to first make decision. I want to model hub or satellite or it's a link. I need to give it a name, and also I need to know if this is kind of a historic object or do I want to receive actually new data for the object. Once you have this like very base shared attributes configured, you go a little bit deeper, and here you wanna create a structure. Speaking about hub, you wanna answer the questions like what's the name of my business key, or does my identifiers mean the same thing across the sources, or is different? Uh, Together with this like object definition plus the structural details, you get a pretty much what you defined in your target picture. And only after you proceed with loading sources. So it's kind of a vice versa, not load the source and then harmonize into one target object, but create a target object first and then plug sources. Here I would like to move on to actual definition of a YAML. So give you a little bit brief understanding of what we've defined and how you should proceed with populating these templates. As mentioned at the very beginning, you want to go from your target picture. You need to answer these very basic questions with uh, what's the name, what's the loading type, uh, do I want to concatenate business keys, right? You usually put these questions to the different objects. So these questions would differ from hub to link. On a link level, you might define in these structures, for example, connected hubs, right? You want to say to what hubs my link connects. Uh, And after populating these values, it is translated directly to the structure. And here we go pretty easy. So for this example, I go with the hub customer. I know that it's a hub. I expect new data. This is done by attribute, and it'll be refreshed. But also I have few attributes related to my keys. In this case, again, very simple. I expect only one source column to be mapped, so I don't need to concatenate. Also, all my identifiers are unique across sources. I don't need to do any source business key, plugging to my keys. And very simply, I define that my business key is going to be named by SBK. This then is transferred to the structure of pretty standard hub. I believe everybody is very familiar with this structure. At this point, we might proceed with actually plugging the sources. And for the simple example, I will show you how to plug two sources. It's going to be a simplified SAP table for a customer and a Salesforce table. So let's start with the SAP one. On the left-hand side, you can see the template for the source, for plugging sources for a hub. All what's green is basically what you type as a modular, and what's black defined or comes from a template. First of all, this is a list of sources, so you might plug them as many as you want. We don't restrict you in this way, but what is important, it has a unique name, and the unique name is done by the identifier on the top. You can think about it as the internal ID. The same way we use another ID towards the sources, so we might, or by this we can make a connection in the background and know about what are my column names in the source, etc. What's important when plugging to sources is provide source schema and table. Here we do by entity source, and this is a tuple or triple, in this case tuple, as a schema and table name. This is a standard table for SAP customer data, where we map the column called kunNR, you see the IDs on the right hand side, towards the key we defined on the top, which is named business key. It's quite simple, but your templates could get quite long if you plug many sources. In the same way, you can do the Salesforce. The only difference is that you use the different source tables, source schemas, in different columns, but the structure you use, it doesn't change. It's all the time the same. You don't need to think a lot about how to write these templates because you can easily copy paste them, and this logic lets you spend time on your source data, see what I can do if you need to concatenate or not, if you need to plug source business key or not to, but focus more work to your research than to typing or modeling those templates. If we stitch all together, having a hub with two sources, it's nothing more than the template you see on the left. What's approximately 20 to 30 lines of code, which is pretty standardized. And it's also decoupled because enter the template, which you see, is stored as a one file. What offers you then parallel processing, for example, later on when we speak a little bit about the performance. But let's imagine now that you are happy with what you coded, even though there is only one hub, and you want to process further, like what you can do actually with these templates. Standard workflow with our tool is that after you model your object in whatever tool you pick, it could be code editor, in the end it could be even Notepad because it's text-based, based on your preference. You have a pair of commands, and it's really the pair. You can use validation or validate or generate. The validate command validates everything what you typed into the template because there is nothing like real-time validation, and this is a text-based. So there is no way, for example, how to figure out if you have a column in database or not without proper validation. That's why this validate command, it checks if the template has a format it should have, and this is really strict. It has to contain all the defined keys. It checks like if you do not break any data vault logic, meaning your relations, it should follow the data vault 2.0 methodology. And as well, we check against information schema. So if you type kun and r as a column you will use for your customer, it has to be there in the table you specify in the source. This is all what's kind of like simply hidden by this validation command. As well, we use the generation. This one generates the deployable code. This case for this demo, it's going to be Snowflake Dynamic Tables. I'll show you later. On the top, you might have a deployment pipeline depending on how you interact with the tool. This could be either like a standard deployment with you can discuss with those guys, or you can do it on your own in case you are more like a one-man show data modeler. You might heard me to use a word. It's a command, right? And also you saw that we were not so enthusiastic about the GUI-based solutions. The tool I'm going to show you, it's a command line tool. So you interact with the command line with the terminal. No worry, it doesn't have to be that way. There are like two ways how you can interact with the tool, which I'll show you in this architecture setup. The easiest one, if you are data modeler, which comes more from the business side, it's not like so technical. You can create your YAML template in your tool of favor. Either it's a code editor, or it could be even like a plain text editor. It can be Microsoft Word if you are really enthusiastic about the tool. All what you have to ensure that the YAMLs you create, you version them. Version them in a tool, again, based on the setup. It can be GitLab or Azure DevOps, whatever you pick as a repository. Usually those tool comes with a visual interface, so you don't need to interact with the terminal. On the other hand, there is a pipeline which is set up somewhere in the background, which does these commands for you. So it picks up the templates you wrote, and it validates them, generate, even deploys. So on your end, you don't have to use this CLI tool. But if you are slightly more technical, not a lot, I'll show you that it's not rocket science, you can install the tool and work directly on these YAML templates. The benefit here is that you really get a performance boost. Also, if you are trusted or you have a connection to the client's database or your own database, you can plug the credentials and you can enjoy also pre-generated deployment scripts, which you can easily run and get your changes directly to the database. With that said, I would like to show you what it is and how it feels to work with the tool. Now I switch into code editor, so I'm in VS Code. For those who don't know, in the middle we have a big panel where you can open your code. At the very bottom there is a terminal. This is a command line you can interact. On the left side you have your folder. Here what you see, we have a configuration file. This is exactly the connection to the database. I store their connection string. But more importantly, we have two folders with two different models, with two different YAML templates. I will start with the demo one. This is a simpler one, but to explain to you the one more file which I will use heavily, it's a make file. You can think about this make file as a cookbook. It's really the cookbook with a bunch of recipes. So let's start with a demo example. We do not limit you how you want to structure your template. So it could be even if you put all the YAML templates into one folder, you are free to do so. In this case, we split them based on the type. So we have one hub and one satellite. Let me open a hub. It's pretty standard template, quite similar to one I showed you with Eldaria, but there is a small difference. In this case, instead of having one SAP source and one Salesforce, I have two Salesforce sources. They split by region. So here we go with the Salesforce America, here with the Europe. The thing is, because I assume the same structure of underlying data. This is just for simplification. As well, I will show you now an example where the same key can actually be part of both sources, but could mean a different thing. So this ID could be different person in source America than in Europe. In that case, I switched this flag and I said I require source business key, but by setting from false to true. At the same time, we have here one template for a satellite, and I told earlier you get only what you type. So in this case, this is a satellite for America. For Europe, you do not have this satellite unless you create one. And this is exactly the task I want to show you. Since this is a text-based, you can search and replace, or you can even copy-paste your templates. They follow the same structure, they have the same properties. So what you can easily do is just like copy-paste, create a new one. Also, here is a easy navigation. In your code editor, you can easily reference and search by the name if you need to cross-reference objects. But this is a pretty simple example. Let me just copy paste the source, which I will use to change my template. At the very beginning, I want to rename the file for me. It's easier for your understanding. Also, I want to rename the satellite. By simply copy pasting and changing the name to Salesforce EMEA, it's enough what you need to do. The entity source structure might slightly differ between the objects. Here, on a satellite level, we define the source again by tuple, but it's on different positions. Nevertheless, since we know that for a hub, we have this tuple schema source for EMEA with a table of contact, I can use it here, and I just replace America with EMEA to get a proper source. And for the illustration, how the validation works, I will remove the source business key. I know it doesn't make sense because in this case, if hub creates a hash key as a source business key plus actually the ID column, in this case you won't get it. But for sake of showing the validation process, I will remove. Also, earlier I mentioned that you have this cookbook which you can use. And this is exactly what I want to do. The cookbook is called a make. So simply just typing a make will run the command which is wrapped behind. You don't need to think about it. But you think that this cookbook contains a lot of recipes, and one recipe is a validate. And just calling this recipe, it runs for me maybe slightly more complicated command, with, which takes this demo folder, sends it to the server where it's processed in memory, and then sends back the result. And here we go. You see that I made this mistake with the source business key, which server tells me that, hey, you would actually create or generate invalid code. Please go back and correct something. This is also, you get like instant feedback. The development loop with this code-centric approach with text-based YAMLs, it is quite fast. So to ensure that I have a proper key, I will go to my connected hub, which I can get from the message as well, and to my correct source, and I see that it uses business key Salesforce ML, so I just copy the one, put it back, run the validation again. In this case, I am receiving the message that, okay, your model is valid, and I can continue with generation. The generate command, by default, it contains validation as well, so it can't happen that you will generate something what is not valid, but you can go with simply just the validation. Now let me run the generation. Again, I use this cookbook, and the recipe is called generate, so let me call make generate. In background, it's again slightly more complicated command. What initially it does, it just says like, okay, this is my model, which take as an input, and here's my output folder. Switching back to my structure, you might see that I got this new folder, which is called demo generated, which is actually the folder which stores all the generated code, bunch of artifacts, but also the sequels, just visually checking. You don't need to care a lot about the generated code because you can generate from any point of time and it's quite fast. What you care is actually the model. But now let me show you how fast you can get actually into your database. Again, I will use my cookbook. So I will tap make, and I have their command which is called deploy all. So by simply hitting make deploy all, it will take what's in this generated folder and utilizing the SnowSQL, it will send all the scripts to the database, and within like tens of seconds, your model is there. Here you might say like, well, okay, you are showing me here one hop and two satellites. I can do that manually. And it will be kind of the same speed, right? Let me show you something more complicated now. I will close my open folders and quickly jump to my cookbook. This is not important. What I need to do, I need to switch my repository. So instead of using a demo, I will go to one which is called global asset. And this is all what I need to do now with my cookbook. And let me close it. Global asset is a production model which consists of approximately 2000 of data vault objects. Here we use full palette with hubs, links, satellite references, etc. The use case I want to show you now is about bringing a new column to the satellite, which can then be picked up in a layers later and maybe propagated to your data mart. For a sake of simplicity, I prepared this use case. Again, what's important, it's up to you how you structure your code. Here it's on the split by the object type or your data vault object type. But on a satellite level, you see that I'm splitting between my source system and it's easier for my navigation. Let me open an example. It's going to be satellite order. I prepared here the code. So by simply adding a new item into your list, which is part of historized column, you are saying that, okay, this satellite will have one additional column, one required from business. Again, the change is quite fast. Now, we won't run validation because I did my job, my pre-work, and I am pretty sure that the object is there in my database. Also, it does not make sense to generate a full model if I do such a small change, like changing one object as a satellite. That's why we include something like a partial deployment, so you can move like faster, get your data, but not only faster get data to the database, but also reduce the cost and overhead. Also, what I want to show you here is that you are free to use your cookbook as you want. So you could be your own chef here with this like code-centric approach. So you might combine your recipes. Imagine that you want to do baked potatoes as a recipe and in the same time to do a meat. In this case, you can combine the deployment and generation as well. Here I prepare my command for that, which I run and explain what's happening. Now my recipe is called deploy dynamic table, and it consists of two stuff. On one hand, it generates my code. On the other, it partially deploys. Again, by saying that my mode is a partial include, I'm letting the tool know that I want to deploy only objects which are in the next parameter for this object list. In this case, I want to deploy only satellite Americas over there. Simply by constructing your cookbook, you can be super efficient. And now you see that with one command, which ran with the validation, because validation is part of generation by default, I deployed my Sat America order with adding a new column into the
Ja, die
database.
ganze Verbindung zu euch war.
Sorry, I don't understand. Okay, let me continue. Yeah. So with this, like having a code-centric view, not a code-driven, you don't need to spend a half a day to making your changes. It's really fast to get there. And it's not a. And now I got to the second part of like how you can fully get the potential of underlying technologies, and that's the Snowflake Dynamic Tables. I will switch to my presentation. But, with a brief explanation on the performance improvements. The model I showed you now, which was generated, contained approximately 2,000 objects. And for those 2,000 data vault objects, we generate approximately 3.9 thousand dynamic tables, which runs in background. But this allowed us, in not only due to the dynamic tables being a really good product, but also by leveraging this modularity parallelism, which is offered by Snowflake, to get the refresh of your silver layer from 3 hours to 6 minutes for these 2,000 objects. Also, the dynamic tables, for those who do not know dynamic tables as a standard object of Snowflake, they are they can refresh itself. It means that you don't need any orchestration on the top. So your process could completely cut tools like Airflow. And here you again reduce a lot of complexity, which is brought into managing your data vault, and purely stick to dynamic tables. Same goes with the migration scripts, which you can directly cut off. I showed you this cookbook done by a Makefile. The one on the top with all the recipes, you have to done it by yourself or use a sample template, but mostly you are the one in the charge who needs to define the recipes. But with the generated code, we provide like inner makefiles by very simple makefile. You can use this make validate, make generate, which is quite efficient and quite easy to use even for non-technical people. But now let me get a little bit to the underlying technology used here. The technology is a Snowflake dynamic table. It's a standard object. It can refresh itself in a simple words. All what you need to do is to specify how fresh data you want to have. This data freshness is done by target lock. This is one of a configuration parameters within your DDL, so it's slightly special syntax. But on the bottom right, you can see how it looks like. This dynamic table is just in the end combination of bunch of parameters, which says like how fresh data you want to have, or if you want to refresh data when you deploy the table, or only during the first refresh. Or you can say like, oh, do I want to refresh full data or only increments? It also reduces your overhead for database cost when you automate stuff. And then the content is pure select. With that in mind, you don't need to care at all about the orchestration. Everything stays kind of fresh, so you don't need to do it's not that you must refresh your data warehouse every 2 days because it's overly complicated. You see that for the mid-sized company with 2,000 objects, 6 minutes refresh time is quite good. Even though in that specific scenario, they refresh 3 times a day. Also, what comes out of the box with Snowflake and utilizing dynamic tables is a built-in monitoring. So as you have, the DAX for airflow and all the maintenance with your code, you can easily go to the UI and see like, hey, this table crashed, maybe set up alerting on the top. This everything goes with dynamic tables out of the box. You don't need to do a lot. With that said, that's in a nutshell how we tackled data vault modeling with a very code-centric approach, with very template-driven, as we believe the data vault is very structured and your templates could be as well, and also with a shifted paradigm of having your target model in your mind and start from your targets, not implementing your sources first.
Okay, thank you, Victor. That's very interesting. Has anyone got any questions? I've got one, I think, in here. I don't know if you've been able to answer that one. So he says, what happened to the back group when you change the satellite? So by adding a column, does the program generate and avoid DDLs and ETLs?
So, well, this is the thing. Let me maybe share back. You don't differentiate between the DDLs and ETLs anymore. Your dynamic table is a DDL and ETL at the same time. By simply defining your select, this is also, you can inherit the DDL, you can set your columns even on the top, but it's combination of both. And by setting a lock, it's your like ETL. You don't do anything else. By setting, if you change the template, the YAML template is text-based. So you type something and it doesn't trigger any action. You have to do. So you have to type command, for example, validate, which actually checks like, hey, is my template valid? If I switch back, I can show you maybe on a simpler one. If I go back to this demo one, and in my satellite, for any reason, I make typo, right? So instead of capital I and D, lowercase d, I do ID and capital. And now I run my make validate, it will complain like, hey, this column is not there in your table. You can't use it. The same way, if you want to generate your code, you have to type make generate. And only after it generates the folder in here with all the underlying files.
Great. That's useful. Again, Grzegorz put up a thumbs up. So I think you've answered his question for him. Well, thank you, Victor. That was very helpful, very useful. It's always nice to see more people working in this space with tooling and so on. It's one of those areas where we don't normally recommend that organizations write their own automation, as it takes up too much time engineering wise, and it's good to see a choice of tools out in the marketplace.